Hey everyone, I hope you all are doing great. In this video, we are diving into Unit 3 of the Edexcel International AS Level Chemistry. As requested by some of you, this focuses on practical skills in data analysis, and there are many concepts which are often shown up in the exams. So I will walk you through the important concepts and tips to help you prepare with confidence. Well, best of luck for your upcoming exams. If there is any topic you are struggling with or you want more clarification on anything, just drop a comment below and I'll be happy to make a video to help you out. Let's ace this together. So this question is about the flame test. You have to outline the experimental procedures to explain the flame test and prove that the sample contains potassium ion. So you know potassium ion, potassium will give you lilac flame test. Okay, so you have to just outline. By the way, this outline is a command word, so every question has one command word and you just need to follow what they are asking exactly. So first thing is you're going to use the wire for the flame test, so you have to be very specific which wire you're going to use. So nichrome wire is what will be used. You can also use um, nickel chromium alloy wire, or you can use platinum wire, because all these wires have high melting point, by the way. So you're going to use nichrome wire, and then the next part is you're going to make a paste of your sample. So what you need to do is you need to add few drops of HCl to your sample to make it in a paste, like a kind of a solution, so the sample can easily stick on your nichrome wire. And then you are going to take your nichrome wire, which is already having a sample on it, and you're going to place it on the flame. And if you see lilac flame color, this is the confirmation test of potassium ion. So how you're going to get 4 marks? The first mark is for the keyword is nichrome wire, platinum wire, or you can use nickel chromium wire. Second is that you're going to use the acid HCl to make a paste of that solution. Third mark you will get is for doing the flame test, which will be, you have to just write it down, saying that you have to transfer the sample onto the wire and place it in the flame. The third mark is for this point, and the fourth mark you will get is for the lilac. So easy 4-mark question, and you get easy 4 marks. Clear? Let's go on to the next question. So this question is talking about the barium chloride test. Give the color of the precipitate and the ionic equation for the formation. Include the state symbol. So it's saying that the student dissolves some of the solid sample in the deionized water to make a solution out of it, and then added HCl followed by barium chloride. So obviously the sample which we are talking about is potassium sulfate, K2SO4. So we are going to do a sulfate test. So color of the precipitate will be white. Please, I will request you all to just memorize the colors of the precipitate, whether it is halide test, sulfate test, or carbonate test. Learn the colors of the precipitate. Okay, so this will be the color of the precipitate and the ionic equation with the state symbol. So what is happening over here is the sulfate is reacting with barium chloride, and the salt which is being formed is insoluble barium sulfate. So barium, it's in group 2 valency 2, plus sulfate SO4 minus 2 gives you barium sulfate. So that white PPT will be of barium sulfate. Now they are asking for state symbol. So barium aqueous, sulfate aqueous, and insoluble white PPT is solid. So these two answers will give you solid 2 marks. Let's go on to the next question. part of the question is saying that the student was given a solution containing one type of cation and two types of anion. Okay, student warm some of the solution in test tube before adding aqueous sodium hydroxide and then damp red litmus paper at the mouth. So basically, if you know, this test is for ammonium ions, and it is clearly mentioned over here that this gives as the ammonium ions. So the conformation test of ammonia will be bring the damp red litmus paper near the source of the gas, it will turn to blue color. So this will give you 1 mark for this question. And why it's turning blue? Because of the formation of NH3, ammonia gas. Clear? Ammonia gas will always be produced if ammonium ions are present. And the conformation test is damp red litmus paper. The litmus paper will turn blue. Okay, next. To another test tube, the student added silver nitrate solution, pale yellow PPT was observed. The student then add excess of nitric acid, effervescence was observed. Excess of nitric acid and effervescence, something to do with carbon dioxide gas. So this is a test for carbonate. Please again go through the chemical test properly, and if you want, I will upload one small video on how to test for the cations and anions and all these tests which are required for your unit 3 as well, because in unit 2 also some of the unit 3 content will be asked. Now in this, the PPT dissolved. Okay, the student added excess of concentrated ammonia solution to the remaining PPT. The PPT dissolved to form a colorless solution. So this gas is carbon dioxide. The test is for carbonate. So it says the formula of precipitate that dissolve in nitric acid. Silver nitrate is added with excess of dilute nitric acid. So the PPT will be of silver carbonate. And in excess of ammonia, it dissolves. So bromide PPT, when you add excess of ammonia, especially concentrated ammonia, the bromide PPT will be dissolved. So this will be silver bromide. Again, this answer requires a good information about the chemical test. So please learn all the chemical tests: carbonates, sulfates, halides, silver nitrate test. The PPTs are formed of different colors, and when you add concentrated ammonia, what happens? When you add dilute ammonia, what happens? What do you observe? All these things are very important. Okay, done, clear. Let's move on to the next question. So this question is talking about the magnesium reacting with hydrochloric acid and the amount of hydrogen gas produced in the burette, which has been kept upside down. So they are using the burette over here to collect the gas. So you know, as the gas will be collected, the volume of water will go down and you will collect the gas. So in this, it says why in step 2 the amount of acid need not to be exact. So we have to use some calculations. So moles of magnesium ribbon is what we need to calculate. So 0.03 grams upon the MR, you will get your value. So once you get this value, you are going to do the mole ratio. So if you look back, the ratio is 1:2. So you are going to multiply your moles with 2 in order to get the moles of your HCl. So when you multiply by 2, your value would be 0.0024692. Okay. Now let's look at the moles of HCl required. Okay. How much volume and concentration of HCl has been given to us in the question. So you just need to go back to your procedure where you will find the volume and the concentration of HCl, which you are using already in the burette. From there you will get your values. So the volume and concentration of HCl is given to you. you're going to find the moles of how much you are using currently you're using for this reaction. So, and please be careful, the volume is given in centimeter cube, so you have to convert into decimeter cube by dividing by 1000. Okay, so find the moles of HCl which you're using. So you divide it by 1000, you will get 0.025 decimeter cube. Then the concentration is given to you 2. You multiply this to get the number of moles. So it will be 0.05. Now you are having 0.05 moles. You need only the moles of acid required is only 0.0246 and you already have 0.05. This means your moles of HCl is in excess. This is the reason why you can just add approximate number of moles of HCl. You can just add the HCl approximately. That's it. I hope this question is clear to you. So this question is saying why magnesium does not start reacting as soon as the burette is inverted in step 4. So if we look at in step 4, this is step 4. So when you invert the burette, you see this is the magnesium ribbon, and this magnesium ribbon is not in contact with the acid. So if it is not in the contact with the acid, how it will react? So this is the answer for your question. So what you will write? You will say that magnesium is not in contact with HCl. Clear? This is easy 2-mark question. You just need to read the burette reading. So the burette reading shows in step 4 is 46.25 and in step 5 the burette reading is 10.7. So the volume of hydrogen gas will be this minus this, so it will be 35.55. So this question says if there is 2% by mass impurity present in the magnesium which you were using in step 1, so whether this will affect your value which you got for answer D, whether this value would change or no, and this value was of volume of 1 mole of hydrogen gas. Okay, so obviously see it's saying 2% of mass of impurity in the form of magnesium oxide, so your moles of magnesium would be less. Okay, but you cannot account or you cannot give the difference or the effect on volume of 1 mole of hydrogen gas, because it's way too less, so it won't have any effect on 1 mole of hydrogen gas. Next, 2 readings were taken to measure the mass of magnesium used in the experiment. The uncertainty in each reading was this much. So you have to find the percentage of uncertainty in mass. 2 readings, 2 times 0.0025 upon how much was the mass? 0.030. 0.030. So when you solve this, your uncertainty would be around 16.667%. Okay, so now the student wanted to reduce the percentage of uncertainty by doubling the mass of magnesium. Doubling the mass of magnesium will obviously it will increase the production of hydrogen gas. So it's asking, give the reason why experiment outlined in the procedure could not be conducted successfully when you double the mass. So when you double the mass, your volume of hydrogen gas would be more or greater than Burette volume. So you won't be able to get your values correctly. Okay, question 3. State what is meant by the term standard solution. So a standard solution is a solution which is made by using a known mass of a substance. So where the concentration is known. So standard solution is like, I'll just give an example. So if you want to make a standard solution of sodium chloride, for example, so you take 5 grams of sodium chloride and you put it in the volumetric flask and add water up to the mark, and this is how you can make a standard solution. So that's what they are asking for 1 mark. A standard solution is a solution which is made by known concentration. Next question is your 6 marker, and this is a very easy, I would say, very easy, nice 6 marker. Rarely you find questions like this. It says describe the preparation of this much volume of this much concentration of standard solution of ethanedioic acid, starting with crystals of ethanedioic dihydrate. Your answer should include details of the apparatus used and the mass of the hydrate. Okay, so first thing is you have to show calculations as well. So you are preparing the standard solution of the ethanedioic acid. So you have to find the MR of this acid. The formula is given to you. Ethanedioic dihydrate crystals, this is what you have to use to make the standard solution. So you just find the MR, so which will be 2 times hydrogen plus 2 times carbon plus 4 times oxygen plus 2 times water. You just add them up, you get 126 grams per mole. Then this is what you have. Now you have to find the mass of this, the required mass of the dihydrate. So find the moles. Moles will be, the concentration is given to you, this volume is this is concentration, this is volume. Volume is in centimeter cube. Change it into decimeter cube. It will be 0.1. So 0.1 times 0.05, you will get 0.005 moles. Then this moles times the MR, what you got, 126, you will get the mass of the ethanedioic hydrate, which will be 0.63 grams. Then you have to use the apparatus. So which apparatus you are going to use? You are going to use the volumetric flask. It has a reading on it. Okay, and then you are going to add your dihydrate and use distilled water and fill the volumetric flask with the distilled water up to the mark. So you just take this, you transfer this into the volumetric flask, you add distilled water up to the mark, and even if there is washing required, add the washing also into the volumetric flask and let it dissolve. And that's it. There you go. This is how you will make your standard solution, and this will be your 6 marker. So let's see how you are going to get your marks over here. So 1 mark, the first mark you will get for the MR of your dihydrate. Second, you will get 1 mark for the mass of your dihydrate. Third, you're going to talk about the volumetric flask in which you're going to make your standard solution. Then you're going to talk about the adding of distilled water up to the mark. Even you're going to include the transferring of the solid along with the washing into the volumetric flask. That will give you one more mark. And the last, you have to fill up the water up to the mark. You fill the water up to the mark of 100 centimeter cube and mix. So you have your 6 marks, 6 points. Now the twist here is, if you give all 6 points correctly, you will maximum get 4 marks. Yeah, 4 mark. But the way you structure your answer, the structuring gives you 2 marks. So the way you structure, the way you answer your 6 marker depends on the way you write your answer. And the good thing is, when new news is that you can also give your answers in bullet point. They are accepting, the examiners are okay with the answers in the bullet point. So this is how you're going to get your 6 mark. Okay, the next question says, this much volume, this much concentration of this acid was added to the flask. It was titrated with the known. Name the piece of apparatus that should be used to add the acid. So obviously you are going to use the pipette in order to add this much volume of the acid. So P-I-P-E-T-T-E, correct spelling. Next is, the titration was carried out with few drops of phenolphthalein. So acid base titration, colorless to pink. Learn the indicators color change, by the way. Next, the formation of white precipitate was observed during the titration. Suggest the identity of the white precipitate in the formula. So ethanoic acid with barium hydroxide. So you will get barium, it's ethanoic, like remember esters, ethanoate, methanoate, butanoate, oic acid changes to OAte, same thing. It's going to be barium ethanoate. Barium ethanoate. Clear? Next. Okay, so in this question, they're asking you to calculate the concentration of barium hydroxide in grams per decimeter cube. So you have to find the moles. So first of all, let's go back and see the values. Volume and concentration is given to you. Volume and concentration. You can easily find the moles. So to find the moles of C2, my bad, H2C2O4, this will be concentration times volume, because the volume is in centimeter cube, you have to convert to decimeter cube. Your answer will be 0.00125, and as you know, the ratio is 1:1. So the moles of barium hydroxide will also be 0.00125. Now you have the moles, this is mole, volume is 31.55. okay, you can find the concentration easily. To find the concentration, just put in the formula 0.00125 upon the volume, which is 31.55, but this is in centimeter cube. You have to convert to decimeter cube. You solve this, you will get 0.0396. Now answer is asked in gram per decimeter cube, so you take this value and you multiply with the MR of barium hydroxide. The MR of barium hydroxide is 171.3. This is the MR of barium hydroxide. You solve this, you will get the answer 6.79. You can round it off to 6.8 grams per decimeter cube. This is your final answer. Easy 3-mark question. Organic part, my favorite part. This question is about the preparation of 2-chloro-2-methyl propane from the alcohol. Fine, the entire procedure is given to you. You can go through the procedure. The first answer, they're asking you to give one reason related to safety why HCl is added to the separating funnel this much at a time and not all at once, because again, if you add all at once, you will see toxic fumes, acid spray coming from your separating funnel, and this is highly dangerous. There might be splashing of acid because the reaction will be so vigorous, aggressive reaction, that it is very dangerous. That's why we add little by little into the separating funnel. So your answer for 1 mark can be to prevent acid spray. There can be multiple answers. You can talk about acid spray, you can talk about the production of toxic fumes of HCl, or you can say because the reaction is so vigorous, so extreme, the reaction mixture getting too hot, or to avoid the buildup of pressure. If the pressure is too much, it can shoot the stopper which you are putting on the funnel, and that's it. Okay, now for some of you these type of questions can be a nightmare where they ask you to draw, but just get used to some of the common apparatus to draw, because these are some very commonly asked questions in the exam. Draw a label diagram of separating funnel. Separating funnel, I am also not good in drawing, but the examiners are not looking for the exact way you draw. You just need to be very clear about the labeling part. This is your organic layer, and this will be your aqueous layer. Okay, if you want to be specific, you can say this layer is of 2-chloro-2-methyl propane. Okay, so you will get 1 mark for your diagram. This full thing carry 1 mark, and 1 mark for your labeled layers in correct order. Remember, the aqueous layer will always be at the bottom. Okay, next. So sodium hydrogen carbonate solution is added to remove acidic impurities. Give the reason why a stronger alkali such as sodium hydroxide solution should not be used for this purpose. Because if you're, again, same thing, if you're going to use the strong alkali, there will be a reaction happening, and it will react with your organic layer, and you will not get your product, the desired product. It will react, and it can reforms the alcohol back, means your product, which is your halogenalkene, may go back to alcohol. Okay, so this is your answer. The reason is it can react with the organic layer. Even if you write this much, you will get 1 mark. You want to be more specific, you want to explain more, you can say that react with organic layer to reform the alcohol. Okay, simple, easy, 1 mark. Next, the role of sodium sulfate. The role of anhydrous sodium sulfate is drying agent. If you go through the core practical, they have mentioned anhydrous sodium sulfate. Now, in this question, you are going to make some changes before distilling, and you have to give reason for your change. So look at this diagram and try to find out the errors in this diagram. So first error is very much visible, there is no stopper. Look for another error. So if you see clearly, look at the condenser. The condenser is having a reverse flow. The water should go from this side and it should exit from this side. So what change you can do? You can just reverse the water flow. So you can say reverse the condenser water flow. Reason? Because you have to fill the condenser with the water. Kindly ignore my handwriting. And the second one is obviously the stopper. The stopper is missing. So you can say that the second change what you will do is you will be adding a stopper. Why? If you don't add the stopper, the gas will escape and you will not get your distillate. So you can say to prevent gas escape. Clear? This question you have to calculate the mass of this product. If the percentage yield is 70%, density is given to you, mass you have to find, volume of the alcohol which you used was 9. Okay, so to calculate the mass of this product produced, if the percentage yield is 70%, density is given to you, volume in the question is given to you, which is 9. You can find mass easily. Density is equal to mass upon volume. So mass is equal to density times volume. So density is 0.78 times volume, 9 given to you in the question. You will get 7.02 grams. So you got the mass of your alcohol. This is your mass of alcohol. Now you are going to find the moles. So moles is equal to mass upon the MR. The MR of alcohol is 74. Solve this, you will get 0.0948. This is your moles. So this is all happening in we have assumed the theoretical mass is 100%, the yield. Okay, so this is what you get. Now you are going to look for the ratio, right? So now you got the moles of alcohol, the ratio is 1:1, so that means the moles of your 2-chloro-2-methyl propane is 0.0948. You times the MR of the halogenoalkane, which is 92.5, you will get 8.775 grams. Okay, now what you need to do is, they are saying if the percentage yield is 70%, so what you need to do is you need to just 70% of this value. So you just solve it, 70 upon 100 into 8.775. You solve it, you will get 6.1425 grams. This is your answer. Clear?